Now that we have this one beautiful equation for the transformed absolute uncertainty, we can finally make Excel do all of the math for us. So, just to recap, the equation for the transformed absolute uncertainty is the original absolute uncertainty times the power times the transform measurement, all divided by the original measurement. So, let's put this into Excel. So, usually I just put the uncertainty right next to the data. You can put it wherever you want really, but I'm just going to put it there because it looks nice and neat. So, I'm just going to call it uncertainty of square root length, right? Because I cannot be bothered calling it something else, and this is good enough anyways. So, let's just call it that. Pretty straightforward name. Now, we want to put it into Excel, right? We have to remember this equation. So it's the original absolute uncertainty. So in this case, it's the fixed value of 0.001 times the power. In this case, we had a square root relationship, right? As we can see over here on our curved graph. So the power is 0.5 times the transform measurement. So the transform measurement are these ones here, and all of that divided by the original measurements, which are all of these here, which are the same as here. I just copied and pasted them, right? So to do that, we look at this equation, right? So original absolute uncertainty, right, which is equals 0.0001, and then times. And remember that the times sign in Excel is the asterisk, right? The power, which is 0.5, and then times the transformed measurement. So you just click on the cell which corresponds to the uncertainty you're doing. So I'm doing this one right now, right? And then put all of this in brackets, and then divide, so the slash sign, by the original measurement. And if we press enter, you'll see that this is the exact same uncertainty we calculated manually, but Excel has done it all for us. And now we can just drag this down and it'll do all of the math for us, so we don't have to waste our time. Now we see that this uncertainty has a lot of decimal places, and obviously we can't have that. It needs to be consistent with the number of decimal places in our original uncertainty, which was 3 dp's, as we see here. So, once again, remember how to do that. You right click on the cell, format cells, if it ever shows up, number, and then choose 3, and then press OK. So you can do it for all of them. I'm just going to do it quickly because I don't want to waste time. Remember, you have to do it for all of them unless your goal is to fail this paper, right? And of course, I'm pretty sure you all don't want to fail. So, format cells. Come on. Format cells. Number 3 dp's. And there we go. So those are our uncertainties for these measurements. Yes, I do understand that 4 of these are exactly the same, but that's the equation we used, and that's what we got out, and this is how we did the uncertainties for our transformed data. It's not so complicated, but just bear in mind that there is a lot of underlying algebra here, and in case you aren't so good at algebra, you can just remember the equation I gave you at the very end, and that will get you through the whole internal. But it's always good to understand the algebra. So in the next one, I will show you how to actually plot the linear graph and then carry on with the rest of the internal.